So section 3.5 is going to work with the sine, sum, and difference formulas, cosine, sum, and difference formulas. Here they are, and this is kind of a brief overview of how to derive one from the other. If you take the formula for sine of alpha plus beta and replace beta by negative beta, then you can plug that in here and come up with your sine of alpha minus beta formula. Likewise with the cosine formula. Now we need to use these formulas because sometimes we have angles that don't quite match what we're used to. So we might calculate it somehow different. So for instance, we can calculate this as the sine of 60 plus 45 degrees, which is our 105. Now as tempting as it is to say, oh gee, that's a sine of 60 plus a sine of 45, we can't. It doesn't work that way. We have to plug in our formulas. So doing that, this becomes your alpha and your beta. So that's the sine of 60 times a cosine of 45 plus a cosine of 45, no, cosine of 60 times a sine of 45. Look, good question. It won't matter. Yeah, so the order of these two doesn't matter. Sine of 60 is the square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 60 is 1/2. Sine of 45 is square root of 2 over 2. Overall, I've got denominators of 4. This turns into the square root of 6. This turns into the square root of 2. So square root of 6 plus the square root of 2, all divided by 4. You can compare that to the answer that you get by plugging in your calculator. So if I was looking at this and this was a test, I want to make sure that, gee, I got this thing right, I could do two things. First of all, I calculate the sine of 105 degrees, and it would be helpful if I had this in degree mode to do that. So sine of 105 degrees gives me 0.9659, etc. Doesn't mean much to me, but what will mean a lot to me is if this expression gives me the same decimal value. Square root of 6 plus the square root of 2. Oops, I need a plus in here. Plus the square root of 2 divided by 4. Yay. Got it. Now one thing that doesn't work is this up here. Sine of 60 plus a sine of 45. In fact, there should be something that's a glaring error if I did that. Let's do sine of 60 plus a sine of 45. What's clearly wrong with an answer like this? Remember, that's supposed to be what our sine of 105 is. Yeah, if you try to calculate it by sort of distributing that, you would end up with the square root of 3 over 2 plus square root of 2 over 2. Numerically, that turns out to about 1.57. What's wrong about this is that sine and cosine can never be more than 1 or less than -1. Remember, you're on the unit circle when you're looking at these things. You can never have a value for sine or cosine more than 1 or less than -1. So that one won't work. Let's try a different one. Problem number 12. Sine of pi over 12. Now on exams, I'll usually follow this with a hint. And the hint might be something like, gee, pi over 3 minus pi over 4 equals pi over 12. If you work this out in degrees, it might be easier to see. I think that's really pi over 12, I believe, is a 15-degree angle. But the hint really says use the sine difference formula. Pi over 3 minus pi over 4. This is your alpha. This is your beta. And we're going to fill in the sine difference formula. The nice thing about the sine formula is that the term in the middle kind of matches. If I have minus here, I'm going to have a minus here, plus and a plus. Sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. So here's your alpha, and then beta and beta. On these types of problems on an exam, I'll ask for an exact answer. That's going to be something that includes square roots, etc. So I don't want decimal answers. That's not telling me what I need to know. Sine of pi over 3 is square root of 3 over 2 times square root of 2 over 2 minus 1/2 times square root of 2 over 2. And I'll end up with the square root of 6 minus square root of 2 over 4. Let's do one the opposite direction. Problem number 24 looks like this. Sine of 20 degrees times a cosine of 80 degrees minus the cosine of 20 degrees times the sine of 80 degrees. So the idea here is to look at this and decide, well, gee, which of these formulas does it look like? Does it look like the sine sum formula, the sine difference formula, cosine sum formula, or the cosine difference formula? Yeah, it's definitely going to be a sine formula of some sort, because in the sine formulas you have sine and cosines mixed. With the cosine formulas, it's cosine and cosine, sine and sine for both of these terms. So it's a sine formula, and with the sine formulas, this sine is going to match this one. So this is the this is the sine difference formula. You can work this backwards. Here's your alpha, and here's your beta. So I'll rewrite this as the sine of 20 minus 80, or the sine of negative 60. Let's use our even-odd properties. That's negative the sine of 60. Anyone got the sine of 60 on their fingertips? Thank you. Root 3 over 2. Why don't you try problem number 26? Cosine of 40 degrees times a cosine of 10 degrees plus a sine of 40 degrees times a sine of 10 degrees. So similar to the last one, while you work on that, I'm going to switch over to Desmos real quick. All right, so which formula did this one work out to be? Yeah, this is the cosine difference formula. So this is really cosine of 40 minus 10, giving me the cosine of 30 degrees. Cosine of 30 degrees is square root of 3 over 2. All right, one last one like this for today anyways. And that's going to be problem number, I thought it was 24. It's not. 48. Problem 48. So this is an identity. We want to prove that the cosine of pi over 2 plus theta is equal to minus the sine of theta. Now, it's not really going to make a difference for us here. I generally think of this as cosine of theta plus pi over 2. And really what's happening here is that they're saying there's a nice relationship between sine and cosine, that one graph is just shifted from the other. But how to prove that? If you're treating this with an identity, you have to work with just, make me look good, one side, right? All right, supposed to do that in unison and laugh at all my jokes. We're live, right? All right, good. So if we're going to work with one side, probably go with the left-hand side. Okay, cosine of theta plus pi over 2. Any suggestions as to what I can do here? Well, we have been working with some identities and properties in this section. Yeah, cosine sum formula maybe? All right, let's give that one a shot. So if we're using the cosine sum formula, this is my alpha and this is my beta. I think you'll actually like this one. Works out pretty good. So this is going to equal cosine of theta times the cosine of pi over 2. Right? So there's your alpha and your beta. With the cosine, these signs don't match, so plus here, minus here. What's the rest of this going to look like? Sine theta times the sine of pi over 2. All right, so again, your alpha and your beta. But I can simplify some of this. Let's take a look at these angles. What's the cosine of pi over 2? 0. 0. What's the sine of pi over 2? 1. So I get 0 times cosine of theta. 0 times cosine of theta? 0. So I get 0 minus sine of theta times 1, or just minus sine of theta. Okay, and that's it. What that's saying is that if you shift the graph of the cosine, you're going to get the graph of the sine. Well, negative the graph of the sine. Negative graph of the sine is this. Graph of cosine of theta plus pi over 2, same thing. So they're just shifted versions of each other. All right, that's it for today. Let me give you some homework. We'll have to do a few more next time. So to start with, try problems 1 through 35. So for homework, try 1 through 35. You can skip problem 27 and just skip 27. We'll do a couple more of these next time. Have a great one. See ya.